Welcome to our AriserTalent students. I'm your maths teacher Arpita Sharma. We were discussing about similar triangle students in our previous lecture and we have discussed about some theorems. Right students? So we were on this theorem, that is, if two sides and a median bisecting the third side of a triangle are respectively proportional to the corresponding sides and the median of another triangle, then the two triangles are similar. Okay, to understand that, what we have to prove, we have to draw a diagram of this. Okay, so we can understand it in a better way. If two sides and a median bisecting the third side of a triangle, if two sides, these are the two sides and a median. Now, the third side will be this median bisecting the third side of triangle. So, this is the third side of triangle. Now, bisecting it, it will be like this, or let me draw it again. See, this is AB and this is AC, and we have made that. Now, we are having a median of third side. That means we are having a line here that bisect these two in same proportion. Okay, so we'll construct this like this. Okay, now name it like A, B and C. Okay students, now it is saying what? Two sides are respectively proportion to the corresponding sides and the median of another triangle. Okay, so we have to draw a similar triangle, another triangle in which we are also having these two sides may or may not be similar. We are having, okay, so let's suppose that is D, E and F. Okay, now we are having median. Let's suppose here, if this is median, I have to extend it. Okay, so let's name it L and M. Okay, so now it's saying that these proportions are similar. Proportions of what? AB and DE, if you take the proportion, is equals to what? AC by DF is equals to what? The medians AL and DM. Okay, so what we generally do is, we write what we have to prove. So, we have to prove that these two triangles are what? Similar. Triangle ABC similar to triangle DEF. Okay students, so I am going to do something here in this in these two triangles. By construction, I am extending this AL to here, so that this AL will be equals to this line, this particular line. Okay, so let mark it G. Okay, and meet them. Okay, now again in this triangle, second triangle, do the same thing. It's not looking the continuous line, so it is M, and we are having such that DM is equals to what? Some mark it H, and okay students, I am having given that proportions of these two sides, that is AB by D will be equals to AC by DF and AL by DM. Now, if I have to prove similar triangles, these two triangles similar, then look carefully. I am already having the terms AB by DE, AB by D and AC by DF. So, what I am looking for, that I should have also a term here like BC by EF. Now, this is BC and this is EF. So, I want to get it in my equation. So, I just constructed it. Okay, we have just constructed these triangles like this. Now, I am taking this, what? This triangle and this triangle. Okay, and in this figure, I am taking this triangle and this triangle. Okay, so first write down what you have done by construction. So, by construction, student, you have done what? This AL equals to LG, AL equals to LG, and this DM equals to MH, DM equals to MH. So, what I am doing is, I am parting this in two sides, and here I will be talking about this triangle. So, in triangle ALB and triangle what? CLG. What I am looking is this, that this angle will be equals to this angle. Why? Because these two are made up of two continuous lines. So, these are two vertically opposite angles which are always equal. So, write like this, that angle ALB will be equals to what? This angle CLG. Okay, students, these two are equal. Now, see, AL equals to LG by what? AL equals to LG by what? By construction, by our construction. So, I can write it by construction, and this was what? Vertically opposite angle. Okay, so mention all these things here. Now, the third one is what? Look here, this is the median, student. AL is the median. So, median divide this line into two equal parts. So, we will be having BL equals to LC, right? Okay. So, BL equals to LC. Why? Because it's median. Because of median. Now, students, you are saying that this angle equals to this angle and these two sides are equal. Now, remember the 9th class in which we were studying congruent triangles. Now, by side angle side congruency, what I am having is that triangle ALB will be triangle, this L will be here, AL equals to LG, AL, that is AL equals to LG. So, LG will be here and BL, that is BL, will be equals to LC. So, C will be here. So, these two triangles are similar, okay, sorry, congruent. Now, the same way I have explained you here that we have done the same construction here. So, these two triangles will also be what? Congruent. So, write it here like this, in triangle, what and what? Triangle BDM, triangle DME and triangle FMH. What? Angle DME equals to angle FMH. Okay, vertically opposite angle, then EM is equals to what? MF, right, student? This and DM That's DM. DM will be equals to what? MH. So I can again write that triangle DME will be congruent to triangle what? The angle is M, which is equal, now EM equals to MF. So EM equals to MF and DM equals to MH. So DM equals to MH. So these two triangles are congruent. So by congruency, if I look into these two triangles, this side AB, student, this side AB will be equals to this side GC, and similarly in these two triangles DE will be equals to what? HF, right? So I can simply write, implies that this what? AB is equals to what? GC. AB equals to GC and GC is here. Now this implies what? That this is what? DE. So DE will be equals to what? HF, that is HF. So this is equals to this and this is equals to this, right student? Now givens what? AB by DE is equals to AC by DF, right students, equals to AL by DM. AL by DM. Now students, can I write this AL by DM as 2AL by 2DM, because it will 2 will ultimately be cancelled out and it will become all again AL by DM. So these two proportions equal. Now can I replace AB by GC? Okay, and DE by HF? Okay, so do this. This equals to this AB can be written as what? AB by AB is equals to GC and D is equals to what? D equals to HF. So that will be GC by GC divided by HF. Now students, AC by DF, that is AC by DF. So okay, write is as it is. Now 2AL by 2DM. Let's see what is 2AL. AL and this is also AL. So 2AL will become what? AG. Similarly 2DM will become what? DM plus HM, that will become DH. So it will be AG and DH. So 2AL can be written as AG and 2 of DM can be written as DH. So look at this proportion. Okay. Now by this, what is it saying? That GC proportion to HF. Okay, then AC, okay, AC proportion to DF, okay, is equals to AG proportion of DH. Now students, the side of these two triangles are proportion to each other. So what we can say, that triangle AGC is what? Similar to triangle DHF, right? Okay. So do what student? Just note it. I will be removing this part. Okay. Okay. Okay students, I am leaving it behind because it's of our use. Now what I can say is, if by Thales theorem and This is again what we have to prove. Okay. So, by Thales theorem, we have what? This triangle AGC is similar to this triangle DHF Okay, students. Now what? If I represent this as 1, this as 2, this as 3 and this as 4. Now, angle 1 equals to angle 2. Right, student? Because of Thales theorem, these two angles will be equal. So, angle 1 equals to angle 2. Now, look at this figure. Look at this figure here. What you are saying that if I construct the same thing here, what I have done? I have just meet E to H and B to G. Now I can repeat the whole process in these two triangles and in these two triangles. Again, this is the common line. In this triangle it was, okay. So, same proportions will be there and I will be eventually get what? The triangle BGL will be congruent to triangle AL and C. Similarly, I will be having triangle EMH will be congruent to triangle DMF, just like we have done it. So, similarly what? We will be having this triangle 4 equals to this triangle 3, because again these two triangles will be similar, and if these two triangles are similar, angle 3 equals to angle 4, isn't it? So, we can directly say mark it 1, this is 2, now this is 3rd and this 3 equals to 4. Similarly, okay. You don't have to just repeat all the process. You can write similarly, because as angle 1 equals to 2, you can say that angle 3 equals to 4. You need not to prove, but if you start the process, then you will get the same result. Okay. Now, adding 3rd and 4th, what you will get, student? Angle 1 plus angle 3 equals to angle 2 plus angle 4. Now, students, what? This will give you what? That angle 1 and angle 3 is equals to BSE, angle BSE, and this is what equals to, this is EDF, angle EDF. Now, you are having this 5th equation for you, and students, by the proportion given to you, what you have given that AB by DE equals to AC by DF equals to what? AL by DM. Okay. So, by this given equation and by this angle BAC and EDF, we can say what? By side angle side similarity, what? Triangle ABC is similar to triangle DEF, right, students? Hence proved. Okay, students. So, just rewind the process, the complete. This is important question, students. You have asked this question in your NCERT exams also. So, just repeat the process. What we have done, we have we have given these proportions and we have asked that prove this triangle similar to this triangle. What we have done? We have construct AL equals to LG and DM equals to MH. After that, we prove these two triangles congruent and these two triangles congruent, and from that congruency we somehow proved that this line is equals to this line and this line equals to this line. And then we just what? We just snatch these values from here and put these values there, and by here we prove this triangle similar to this triangle, and we have found that this angles are same, similarly proved that these angles are same. Okay, so we proved this angle A equals to this angle D, and we have given these two proportions equals to proportion of these two equals to these two. So by these two things, that proportion of this to this and this to this is similar, is same, and the angle made by these two sides is also same. So by angle side angle side property, what we have done? We have proved it similar. Okay, so mark it, it's important question and note it, students. Okay. Okay, so just mark the steps that what and what you have to do. In most of the cases, like we have done before, we have to just pick some theorems and in one or two steps the result was there. So it's a little bit long enough question, but it's not that tough, right? Okay, students, so I've told you that after this theorem we will do some theorem related to area of triangle. Okay, we were only discussing about the sides, medians, okay, and altitudes. Now we will be discussing about what? The area of triangle. So the first theorem based on area of triangle is the ratio of the area. Why we are studying these things, students? Because we can apply these theorems directly to a given question. If in a given question we are having some numerical values of some sides, we can just apply these theorems on them and got the answer. Okay, students. So the theorem 1 is the ratio of the areas of two similar triangles are equal to the ratios of the squares of any two corresponding sides. So you have to prove this. Now for this, what we have to do? We just draw a diagram of triangles, the ratio of the area of two similar triangles. So first draw two similar triangles. Okay. These are my two similar triangles. Let's suppose that is A, B, C, D, E and F. Okay, students. Now it's saying that the ratio of the areas of two similar triangles are equal to the ratios of squares of any two corresponding sides. Okay. Right, students? So it's talking about area. Now area is what? Half into base into height. Now we are having base, but we are not having height here. So just create height here. So I am creating a height here. Now this is angle 90 degree. That means this is the altitude we have drawn on EF and BC. Now the ratios of the areas, that means we have to prove that what? Area triangle ABC by area triangle DEF equal to the ratios of the square of any two corresponding side. That will be equals to what? AB square by DE square or or we can say like BC square by EF square, or we can say it can be equals to AC square by FD square. So this is what we have to prove. Okay, and we have given what? Given is what? Only thing which is given is triangle ABC is similar to triangle DEF. So we have given this, so we can conclude by Thales theorem the proportions. So just write AB by DE equals to BC by EF that will be equals to AC by FD. Okay, this is one. Now the second is in triangle. We have constructed, you can write construct AM such that AM perpendicular to BC and DN such that DN is perpendicular to EF. Okay. Now students, what? In triangle ABM, this triangle, I am talking about this triangle and this triangle, ABM and triangle DEN, what I am having is angle B equals to angle E, angle B equals to angle E by what? By similarity. Okay students, so this angle is equal. Now we have angle M equals to angle N equals to what? 90 degree. This is what? By construction. We have drawn this altitude, so this is equals to this angle. These two angles are 90 degree. So by students angle similarity, we have proven that this triangle to similar to this triangle. Okay, so just note it. By angle similarity, what? Triangle BMA will be similar to triangle CN. This is C. Okay, I should rewrite it. Okay, so this angle B equals to this angle E. Angle B equals to angle E and angle M equals to angle N. So triangle BMA will be similar to triangle what? E and D. Okay students, so if these two triangles are similar, we have to take this AM and this DN in our equation. Okay, this AM and DN equation. So we can write from there that this implies AB by ED will be equals to AM by ND will be equals to AB is done, AM is done and AB is done, AM is done. So you have left with BM. BM will be equals to what? EN. BM equals to EN. Now students, AB by ED is here and also here. So we can just mark this and this. So what? These all six proportions are equal. So we can write is equals to BC by EF equals to AC by FD. Now student, we are having these six proportion equal and we have concluded in this way. Now what we have to do? We have to take what? area's proportion. Now, so area triangle ABC by area triangle DEF will be equals to what? Half multiply by, here also half, base. Now base is here BC and here EN, here EF. So it will be BC and here it will be EF. These are the bases and the heights. The height is AM here and DN here. So AM here and DN here. Now I am cancelling out this half to half. Now BC by EF. BC by EF is here and AM by DN is here. AM by DN is here. So I can write BC by EF equals to AM by ND or AM by ND equals to BC by EF. So I am just replacing this AM by DN to BC by EF. So that will be equals to BC multiplied by BC, then this EF multiplied by this EF. So what will it give to me is area ABC is divided by area DEF is equals to nothing but what? BC square and EF square. Okay students, but the area, but these triangles are what? Similar. So I am rubbing this portion. So notice students. Okay. So I have given that what I have given? I have given with that AB by DE equals to BC by EF equals to AC by FD. Okay. So squaring given equation implies what? If I will be squaring this to this and also it will be squaring. Okay. So what I am getting, that BC square by EF square is equals to what? This. So by this third equation and this fourth equation, by equation third and fourth, what we are having, that, or else I can say area ABC by area DEF is equals to what students? AB square by DE square equals to BC square about EF square and AC square by DF square. Right students? Okay. So this was what we have to prove. So students, from here you can prove. Note it students, then we will be doing some questions based on this similar triangle area. Okay. We have done only theorem 1 na? Okay. Then no hurries, we are having only one theorem again on this left. So we will be having one more theorem. Okay. And we have to be specific what we have done. We have proved in this theorem, because we are going to take help of this theorem in our next theorem. So what we are having here, area ABC by area DEF, what we have proved, that will be AB by DE square plus BC by EF square plus of what? AC by DF square. Right students? Now look at our next theorem, which is if the area of two similar triangles are equal, then the triangles are congruent, that is equal and similar triangles are congruent. Okay? Okay students. So with this help of this concluded theorem, I will be proving this theorem. So you can do one thing, you can try to prove this, and it's very simple. If you carefully look at this particular proven statement, you can easily prove this theorem. Okay, so do one thing, try to prove this. So we will be meeting in next lecture. Okay students, thank you.